Okay, so more functional groups with this video, this time double bonded functional groups. And double bonded functional groups have, a lot of them have this particular group in it, this C double bond O. And there's the C double bond O, there's the C double bond O, there's the C double bond O bonded to this oxygen. And in terms of compounds, this is an aldehyde. We'll see why in a minute. This is a ketone. And this is an ester with an S. So let's start looking at these aldehydes and ketones. So once again, C double bond O. It's known as the carbonyl group. So a molecule would be classified as an aldehyde or a ketone, and the functional group is specifically the carbonyl group. Now, with aldehydes, the carbonyl group is bonded to a terminal carbon. So here's the carbonyl group, and it is at the end of the chain. I would start numbering here to minimize the group. So it's on carbon 1. So it's at the end of the chain, and that makes it easy. We never need to indicate position for an aldehyde. For the carbonyl group and an aldehyde, it's always carbon 1, therefore the 1 doesn't need to be mentioned. So we name accordingly. 3 carbons, that is a propane molecule, so we add the propan, we remove the E of propane, and we add Al for aldehyde. So Al, aldehyde. So in the second example, we have, there's our carbonyl group on a terminal carbon. That would be carbon 1, 2, 3, 4, 5. So we have a 5 carbon chain. The longest chain is 5 carbons. We have this branch here. Now, we don't need to indicate position of the carbonyl group because it's an aldehyde. That's carbon 1. And so what we have in carbon 3 is an ethyl group. So 3-ethyl pentanal. Ketones, on the other hand, have the carbonyl group bonded on what I term an interior carbon. That is a carbon within the chain. So if we look at this first example, 1, 2, 3, 4, 5. We have a 5 carbon chain, but notice where that carbonyl group is. It's on carbon 3, which means the carbon of the carbonyl group is attached to 2 other carbons. That has to be the case for a ketone, so that's one made by interior carbon. Naming is again pretty straightforward. 5 carbon chain, that's a pentane, so it becomes pentan, and we add the prefix -one. But we do have to indicate position potentially for our ketones. And so where's that carbonyl group? Inside carbon 3, so pentan 3-one. If you look at the second example, there's the carbonyl group. It's on a 4 carbon chain. And so that is relatively straightforward. It's just butan 2-one. So pentan 3-one because the carbonyl is on carbon 3. Butan 2-one because the carbonyl is on carbon 2. Aldehydes and ketones are very commonly used as examples of positional isomerism. As the position of something moves to create an isomer. And so in this case, what type of compound is this? Well, there's my terminal carbonyl group. So this is an aldehyde. I actually also have a branch here on carbon 2. And so it is 1, 2, 3, 4. So that's a butanal with a 2-methyl group. So 2-methyl-butanal. In this case, I have my carbonyl group on an interior carbon. It's on carbon 2. I'd start number from this position to minimize the branch. So that is pentan 2-one. Carboxylic acids are the third type of group we're going to talk about in this video. Carboxylic acids are characterized by this common group COOH. The carboxyl group, and this is what the carboxyl group looks like structurally. There's the C double bond O, there's the C bond O, and that oxygen has a hydrogen attached. That you may recognize as the hydroxyl group. So this would be classified as a carboxylic acid, and the functional group is a carboxyl group. The C double bond O group, the carboxyl group, is always terminal, so once again it doesn't require a number. And again, the naming is pretty straightforward. We simply name the compound based on number of carbons. So this is an ethane. but we take off the E of ethane and we add oic acid, so ethanoic acid. So in this case we have what appears to be a relatively complicated molecule, but because we don't have to worry about numbering, because we know this is carbon 1, we can just basically sort it all out by looking at carbon 1. So on carbon 1 we have our carboxyl group, carbon 2 we have an iodo group, an iodine, carbon 5, 1, 2, 3, 4, 5, we have a chloro group. We'd list those halogens alphabetically, so 5 chloro, 2 iodo, pentanoic acid, 5 carbon carboxylic acid, pentanoic acid. So here's a little bit more practice. We feel free to pause the video if you want to try to answer it yourself, or at least identify the functional group, but I'm going to get started. Here is our functional group, C double bond O, bond OH. So that is a carboxylic acid, not an aldehyde or an alcohol or a ketone for that matter. It's carboxylic acid. One carbon only, so the prefix would be meth. Well, that's actually formic acid or methanoic acid. Formic acid is the common name for methanoic acid and is still very much in use. Formic acid, very much prevalent as a name for what would otherwise be known as methanoic acid. Here's another molecule. There's my functional group, C double bond O. So that is an aldehyde. So just like methanoic acid, this aldehyde has a common name, formaldehyde, which you've probably heard of, but it would be known as methanal as a systematic name. And the last one on this page, if you look at the carbonyl group, that's all we got. It's on an interior carbon, so it is a ketone, and that ketone would be known as propan-2-one. Propane, carbon 2 has the carbonyl group. Here's, again, a relatively complicated looking molecule, but just dial into the functional group. If we were numbered this, we'd start here, 1, 2, 3, 4 in any direction, and so we know there's a carbonyl group on an interior carbon, so that is a ketone. We have methyl branches on carbon 3, we have 2 of them, so 3,3-dimethyl butan-2-one. Again, looks complicated, kind of a complicated name, but you should be able to draw that if you were given that name, because all the information is right there. Here's the last one on this one. Carbonyl group on a terminal carbon, so that is an aldehyde, 1, 2, 3, 4, 5, 6 carbons long, so that is hexanal. Lastly, what's the functional group? C double bond O bond OH in the same group, so that is the carboxyl group. But it doesn't change anything. The fact is on this ring structure, that's in fact a benzene structure, which I showed the other day as an arene. But you can just call that benzene, take off the E, and add oic acid, so benzoic acid. So that is a carboxylic acid attached to a benzene ring. And that's it for these functional groups.